Hello and welcome to the IoT Now podcast. I'm George Malim, the managing editor of IoT Now, and I'm delighted to welcome today's guests. We have Mark O'Connell, the general manager for EMEA and APAC at Globalstar, and also Jim Morrish, the founding partner of Transforma Insights. It's great that you've joined us here today to talk about satellite communications and specifically mission-critical communications within IoT. I think that's a particularly interesting area because of the sensitivity that mission-critical communications have. So I find that a really interesting area to get into. Let's set the scene by talking about some of the stories that we're seeing about satellite communications in the press at the moment. Mark, turning to you first, I think you've got a story that you found was interesting.
Yeah, I found a story about China running a 2-year study on IoT and its rollout, trying to make it more available within their territory. But I think it speaks to the global nature of mission-critical communications and the requirements for networks to be able to provide that on a global platform and to global customers. And I thought it's a small little story, but I thought it was a timely story for our conversation today because it just reinforces the global nature of communications and the global nature of the people who use communications.
Yeah, absolutely. Quite interesting to have a 2-year case study as well. It seems quite a long time frame given the pace of information, pace of innovation.
Correct. Yes.
Cool. I mean, I've seen some things that I think are really interesting about how satellites kind of entering the mainstream. Obviously, we see Amazon Leo and Starlink and those types of low Earth orbit companies coming in on a more consumer basis. And I think that's going to be very interesting. But I read an article in the Sunday Times over here in the UK over the weekend from Danny Forson, who's based over in California. And he was saying that there'll be more than 100,000 LEO satellites circulating by 2035. And he quotes John McDonnell, an astronomer at the Harvard-Smithsonian Center for Astrophysics, who estimates we could see 20 satellites a day re-entering orbit in probably the 2035 or later timeframe. But if you have any concerns about this level of space junk that the satellite industry might be creating?
I guess there might be a concern about the re-entry. As those things, as they drift down and basically vaporize in the upper atmosphere, we're putting what the upper atmosphere might regard as unusual chemicals in it. So it's yet to be determined what the impact of that might be. But these things are all choreographed. It's amazing how they don't hit each other. It just seems to work, and it works around as a network. So hopefully that it continues in that way. They don't hit each other, because that's where you really get the space junk, unless somebody decides to test some of their space weapons and blow up a satellite, which has happened in the not too distant past.
Yeah, I should point out, of course, we're not expecting 20 asteroids of full-size multi-ton satellites to come and land on London or anywhere else today, because they will, as you said, vaporize. But it's, I guess, the minerals and the metals and things like that would be vaporized into the upper atmosphere that might have an ecological impact. But anyway, that's probably something for us to be talking about if we're still alive in 20 years' time. So let's turn our attention to the mission-critical market, which has always been a strong market for satellite because of the ubiquitous coverage and the resilience that satellite networks have, which simply aren't there in alternatives such as cellular and other things like that. I think a great way to frame the discussion would be to start by asking, what does mission-critical mean to you when it comes to communications? And I'll put that to Mark first, please.
I think mission critical has a couple of different definitions, and it depends on the ultimate user of the units. I mean, at a very top level, it's to do with, ensuring safety in natural occurring events such as storms, earthquakes, and what have you, for first responders to have appropriate and efficient and reliable communications in those events. And that's probably what most people, if you ask them what is mission critical, they would think of first responders. Also within organizations such as utility companies, local governments, being able to provide infrastructure communications to lone workers in the field who are outside of GSM coverage is a key point for them and is a mission critical to be able to comply with their regulatory requirements, but also to be able to provide that sense of safety to their employees, that if there is an issue when they're, going up a pole to repair a line, possibly in a storm, that they have an ability to get help immediately once they need it. It is key, and that's mission critical for those organizations. Okay. And if I broaden it out, if I look at ranchers in America or large station owners in Australia who have remote water tanks and remote troughs, being able to accurately monitor the water levels in those is mission critical to them, because they want to ensure that their livestock have adequate access to water to ensure that they survive and they grow and they prosper. But also it's critical that if there's an issue, they can identify that issue early on and send somebody out. Some of these branches and stations are vast, and cost of sending somebody out to correct an issue is huge. So being able to get that accurate information is very important to them. Similarly, for farmers in Norway who use a collar from one of our partners, Find My, which is enabled by our SDX3 chip, it's important for them to be able to get the sheep back in late September before the winter closes in, because, you know, they go out for the summertime, they graze in the mountains. Mission critical to them means getting them back in at the end of the season. And you can look at those who transport hazardous waste, knowing where it is and what the conditions are around it. One of our partners is having involvement in that sphere. For them, the information coming from that is mission critical. So if you're looking from ag tech to transport hazardous waste to monitoring oil lines, the definition of mission critical depends really on the user, and each user has their own definition of that. So when we look at from our perspective, we look at it as, what does it mean to our customer? What does it mean to our partner's customer?
So we're going from the value of one sheep to an individual farmer to avoiding an oil slick in the Alaskan permafrost and all the penalty charges for that as a spectrum of criticality. But I guess criticality is always in the eye of the beholder. Jim, what's your kind of definition of mission critical?
Yeah, I think my view is very similar to Mark's. I think you summarized it very well when you said criticality is in the eye of the beholder. I think when you first say to someone, hey, this is a mission critical solution, they're thinking loss of life, and it's these like really extreme cases. But in reality, this is a commercial world. What is mission critical is defined by the person that's buying the service and what really matters to them. And mission critical satellite is critical in situations that is really the only option. And if it doesn't work, then alternatives are really painful. And that's either a really painful way of finding some alternative communication or losing the communication, and that having knock-on consequences. I mean, Mark was giving examples about monitoring pipelines, etc. If the solution there fails, there's potential painful consequences to that. So that's when it's critical that satellite comms work. It's really about the perception in the mind of the person who's buying it and what really matters to them, what their mission is, and enabling that mission. And as Mark says, that extends across multiple industries and contexts, from defense and government, which might seem more naturally sort of mission critical, and disaster management and emergency services and so on, but then on to things like critical infrastructure and SCADA and the systems in power stations and the pipelines that have been mentioned, maritime offshore operations, remote environmental agricultural monitoring, agricultural solutions, finding horses that are grazing on the steppe in Asia. They could be distributed across a huge area to the person who owns those horses, knowing where they are, and they could be anywhere within 1,000 kilometers, really matters. So I think it's in the eye of the beholder, as you said.
So moving on slightly, I mean, satellite always has this heritage of being a high quality yet expensive option, and that has precluded lots of use cases in the past, and perhaps confined satellite only to use cases that can support the cost via their business case. So yes, it's fine if you're saving a horse or a sheep. It's well worth the cost of a tiny satellite asset tracking communication, which can easily be understood. However, if you're in a very large, massive IoT deployment, it's probably not worth a non-essential sensor being able to ping across 100,000 devices. There are cheaper alternatives that cellular can support or something like that. So my next question is, what has been the biggest change in satellite technology that has taken it from being this kind of exclusive technology to support high-end use cases to a far more widely available technology with much greater applicability? So Mark, what's the biggest change that has kind of opened up satellite to a raft of new use cases?
I think the cost of satellite has come down significantly over the years. If I look at the cost of manufacturing a satellite and launching it, those costs have come down significantly over the years, and that allows operators to pass that cost on to services and lower service fees to partners. But I also look at the satellite devices; they become smaller, more ruggedized, more power efficient, which means they can last longer in the field. And if you look at most satellite deployments, this would go up for about 15 years. And the product sets that are produced to work across them are rugged, long life, low cost of operation, low cost of ownership. And over the period of the lifetime of the asset, it produces a very good ROI for the customer. And I think added to that, from the cost perspective of it, okay, if I look at terrestrial networks and the movement of in 4G, 5G, and 6G, when it comes through, and it will come at some point in time, I assume, are all population coverage now. Terrestrial networks would be population coverage networks. Satellite is now becoming much more operable in areas with it. And because of that, we're getting economies of scale because more units are being deployed, which means you manufacture more units, means the cost of the units coming down to get opportunity and scale from that. So I think they're the kind of things that have brought satellite to be more affordable for everybody, and not just maybe on the exception use case, but also on large scale rollouts where, they're going to go beyond, in many of these cases, go beyond cellular. So they're going to need, or terrestrial, they're going to need to have a satellite component. And I think LEO provides that cost efficient, power efficient, and reliable service for it at a price that makes sense.
Great. I like that. I mean, I like the ecosystem maturity point as well, because I think that makes the technology more widely applicable. Jim, what's your view on democratization of satellite connectivity, but also the hardware as well?
I tend to agree with the thoughts that Mark has expressed there. I think we're very much in a sweet spot at the moment, and it's just kind of a sweet spot of a network effect almost. I better unpack that a bit. So launch costs have come down, satellite costs have come down, so that side of the equation, really is getting a lot cheaper. Those LEO constellations are becoming much more feasible. Meanwhile, I think I'd emphasize non-terrestrial networks and the 3GPP's initiative there. Now, that hasn't resulted in broadband connectivity yet, which is what it will ultimately do. But what it has done is it has illustrated some of the things that are possible. And it's invigorated the market, I think, to think what can be done with satellites. And we've also got some real examples. Mark, I'm sure you're intimately familiar with Apple's emergency SOS via satellite. Now, everyone's heard of this. That is a handset to satellite solution. And just having that solution out there, people realize that this kind of thing is possible, and they begin to look at satellite in a new way. There are other US operators who are developing equivalent services. I mean, T-Mobile's doing something, Verizon, AT&T as well. So it's becoming real in the environment which people are just living day to day, and folks are becoming aware of what can be done. So what you've got is this kind of network effect. So things that have been possible for many years and decades, in fact, suddenly have become a lot cheaper, and people are much more aware of them. And between those two things, I think it's really accelerating the market.
Makes sense that kind of multiple sources of momentum, I think, driving things forward. The other thing is, which I think we all touched on during this conversation, is the better integration between cellular and other technologies that creates a wider set of options for connected devices to utilize when they're in deployment. How is satellite in the mission critical world being used as a backup or failover to cellular networks? Jim, what's your view on satellite as part of a wider mix? And specifically when it comes to mission critical, how does that integration of satellite with other technologies create that robust and resilient foundation, regardless of technology, to support mission critical communication?
Okay, thank you. It's an interesting question. I think you've touched a bit on the answer with the question in using the words failover, etc. And I think it's worth emphasizing that there is kind of a hierarchy here. If you have a device which could connect via a terrestrial network or a satellite network, in most situations, most of the time, preferably it's going to connect via the terrestrial network. However, terrestrial network coverage is not ubiquitous. Within territories, within the US, you've got large blank areas, Australia, many other countries, there are areas which aren't covered. And that is where satellite becomes critical. And even in reasonably densely populated countries, there can be areas which are not covered, and those can be the areas where the connectivity really matters. So, for example, if you have a vehicle tracker or an e-call solution and you have maybe 95% coverage, as you might have in many European countries, and if the car breaks down or there's an accident in that 5% that isn't covered, that's when it really matters, which kind of brings you back to the criticality aspect. And satellite picks that up. So what you've effectively got is filling in the not spots of terrestrial network, providing a ubiquitous fallback in case there's a problem with the terrestrial network. Closely related to that, of course, terrestrial networks are fragmented country to country. There's a different terrestrial cellular network in each country, whereas the satellite alternative could be much more homogeneous across countries, across geographies. So it's about peace of mind, I think. It's about knowing that there is a possibility to communicate almost no matter what happens. And again, there's an ecosystem effect associated with that. The standardization of devices, again, the 3GPP initiative, where you get devices which can connect to cellular networks and satellite networks, that drives scale, drives down the costs of those devices, drives up the number of devices that can connect to satellite, etc. So again, I think it's kind of a right technology, right time.
Yeah, that's a great response. Thank you. Mark, what's your view on blending multiple technologies together to kind of optimize cost, but also optimize resilience?
I think you got to look at it from the perspective of mission critical communications about the confidence that the network is there when you need it. Okay. And I think, to Jim's point, if a cellular network is there, of course, people are going to go over that network, the volume of traffic and the cost that is going to happen with that. But the reality also is that there's many parts of the globe, including in Europe, that do not have cellular coverage because within in a dark spot or it's just outside of the coverage area. And thinking about mission critical communications, they need to have the network that can do that. So you see with our RM200 product, this capability of merging satellite and terrestrial gives options for people to be able to develop product sets that can operate in cellular where it makes sense to do that. And when it fails, that goes away, it fails over into satellite seamlessly. And I think that's where very much the market is going to go in terms of being able to have networks that can produce a seamless communication for the end customer so that they have that communication, whether it's they're in the middle of the city or they're out in the countryside in the US or in Europe or in Australia where they run out of terrestrial coverage. Or there's a significant event that impacts terrestrial coverage. It can be a major weather system, which we're seeing these in Europe now more and more. We see them in Ireland, we see them in the UK, in Europe, we see them across the globe that impact cellular service, up to and including such things as the power outage in Spain and Portugal earlier this year, where the entire grid went down. Having to have a network that seems to fail over from cellular into satellite is hugely important. So I very much see satellite as very much part of the fabric of mission critical communications going forward. And that integration between the two in terms of satellite and terrestrial working together will very much be, I think, part of the future.
Do you think there's a significant implication with cybersecurity here as well, that you could have bad actors attacking all the cellular networks in a specific country and then being able to fail over to satellites, obviously good, but there could be wider issues that take down parts of the network, and having a satellite almost as an overlay provides greater critical capability than not having it, and therefore there's a justified business case. Is that something that concerns you, Jim, as we look at cybersecurity?
Yes. I'll pick up on the diversity point within that particularly. So if I spin back 30 or so years, it's my early days in the telecommunications industry, when you were connecting a building, one of the things you made sure is that you put the cable in the front of the building and another cable out of the back of the building. You did not run two cables through the same ducts because that was a single point of failure. And this is one of the things which satellite offers us. No matter what happens to a terrestrial network, and in these days of RAN sharing and site sharing, that can be one site that supports multiple networks, or there could be local peaks in traffic, etc. So there are things that could go down in terrestrial networks. No matter what happens, you have an alternative channel. So that security that is enabled, the application security of the proposition to the end user, I think, yes, is very critical. And I think it is very much something that satellite enables. And we're beginning to see examples of this, where, for instance, wind turbines might be connected via terrestrial networks, but many of them would have a satellite backup on them to make sure that they always work.
And Mark, do you have any views on the increased threat surface and increases in cyber attacks? Does that actually play into your hands and make people want more backup and more alternatives?
I think it's part of. I think satellite provides that ubiquitous coverage that other networks don't. I think by its very nature, there's fewer contact points, so they tend to be controlled amongst networks. And because, we own our own networks, we own our own infrastructure, we own as well as everything from beginning to end, we can control more efficiently what's going across them now. So I think the satellite can provide that backup where those attacks happen and cause issues in terrestrial. Satellite can provide that backup and support and ubiquitous network that key information can be still transmitted across our network to those who need it.
Okay, great. Let's look ahead now. And unfortunately, I think we've got this far without mentioning the two letters that we have to mention in every conversation in technology, which are A and I. What do you see as the next steps for mission critical satellite communications? Obviously, we're seeing increased automation across the automotive sector, the use of robots in areas such as senior care, and the application of AI and increased reliance on connected data to power insights. What will satellites' role in all of this be? And I'll put that to Jim first.
Challenging one.
So tell us the future in one sentence.
Yeah, exactly. So yes, we do have to mention AI. One of the things that is particularly critical for AI, though, is homogeneity and continuity of inputs, fragmented inputs, disconnected inputs, out of context inputs, etc. Make doing AI a lot harder. So again, I think it comes back to this potential to continually track devices and continually monitor, get data from those devices when they're connected to a homogeneous network and a network that is supporting communications to those devices in a similar and homogeneous way, no matter where they are in the world. That provides the raw information that you need, I think, to effectively apply AI to monitor a device's state. And of course, in terms of putting AI on these end devices, again, a good quality, consistent connection allows much more agility in terms of where you're going to put which bits of an AI process, what we're going to put on the device, what you're going to put remotely, and also updating those AI engines in a secure way. So I think it's part of a picture, part of a tapestry.
I guess it kind of neatly comes back around to criticality as well. That if AI is fundamental to whatever business process or life process is involved, so is the ability to connect AI to centralized servers and whatever to manage the data flows. Mark, what's your view of satellites' role in this automated AI-enabled future?
I think satellite provides ubiquitous coverage applications that other networks can't. For AI to work, it's got to get the inputs, as Jim has said. So you need networks that can provide that no matter where that input's coming from the globe. And I think satellite provides the foundation assurance that you can get that information when you need it, so AI can keep doing what it's doing. I think also the increased innovation in satellite networks and product sets, it brings the cost down, makes it more efficient, makes it more appealing to organizations. And I think also continued integration to NTN device with NTN and those devices coming forward will provide more solutions for people to track the information necessary for AI. So I think satellite is a key part of this. I think it provides that ubiquitous network beyond cellular, and when cellular fails, so for that information to come through. But I also think in tandem with cellular and NTN and developing new solutions, I think that's going to further grow those markets out and going to further grow the opportunities for people to trap data necessary for the utility to do what they're supposed to do.
Yeah, if I can just pick up on that new solutions point, because there is another dimension to this. It's the degree to which AI drives satellite connectivity. And there is a clear dynamic there, which is particularly around redaction at the edge. So there might be a video camera, and that video camera could stream out high bandwidth information. But if you put AI on board that video camera and just say, well, tell me, just send an alert if somebody comes within, crosses a certain boundary within an industrial facility, what you've done is you've massively reduced the amount of information that needs to be communicated. And what that does is makes many AI-enabled solutions much more feasible to deploy via satellite in much more remote locations. So there is very definitely a dynamic that way around.
That's very interesting to look at the ability to apply AI to and edge intelligence in general. It doesn't all have to be artificial intelligence.
It does nowadays.
yeah, true fact.
And to Jim's point, that actually greatly reduces the cost of the service and makes it more easily to deploy and in greater scale, because you're only trapping the information and sending the information that you truly need and not every piece of information.
Yeah, which is, again, a way to optimize, control the costs, reduce congestion, make everything more appealing, which I guess has been the unifying theme throughout today's podcast. But the satellite has transformed itself from being this kind of elitist, geostationary Earth orbit situation in which very high cost for very high value use cases. And as the costs of launching satellites come down, so have the costs of terminals, and so have software which enables the actual payload to be optimized and therefore reduces costs. Also, one story I've seen recently, it's more in the NTN space than the satellite space, is high altitude platform stations, which are basically UAVs or air balloons that are attempting to, in the stratosphere, deliver large scale communications of the sort that satellite does. There are loads of problems with this technology, though, and it's taking a very long time to come into fruition, which, I mean, we've even seen Google give up. Interestingly, their effort was called Loon, which I thought was kind of amusing, but they gave up after 10 years in 2021. Do you, Mark, see those kind of NTNs and kind of stratospheric types of technologies coming to fruition, and do you think that's a threat to your business?
Well, look, I look at it more from a Globalstar perspective. We're one of the longest standing satellite providers. Okay, we've a proven network over decades. We're purpose-built for mission critical communications. As I said, we've been doing this for a very long time. I think that helps us set us apart because people can have assurance in our network that we will provide the communications when you want it most, and we'll track the data that you want most. And I think that's hugely important to people when they're looking at mission critical systems, that, they want the surety that it's going to be there. And I think that is a key part of it. Okay. Allied to that, we then have an ability to have an end-to-end ecosystem. We can give you the chipset to build out the product that you want to service a particular critical need. If you want to have an off-the-shelf product, we have that also. We can also provide you with a fully built product, be it for asset tracking or monitoring, or indeed for providing a solution to your people in the field. We have that as well. And then, we also own and operate our own satellite network and have done so for decades. And that gives the surety that the service is there, so we can provide you with the service as well. So we can take somebody from the very beginning right through to the provision of the service and assist them to do that in a very controlled and reliable, cost-effective manner. So
I struggle to sort of put my mission critical faith in a kind of modern version of the Hindenburg and deal with the idea that there'll be UAVs that need to be replaced every 6 days to recharge themselves and things like that. It doesn't seem a very mission critical set of characteristics to rely on. But Jim, I wondered if I could bring you in on that point as well. Do you see that having an impact specifically in mission critical communications?
Not particularly, no. So for anyone who's been knocking around in the broader telecoms industry for a while, Halo is one of those kind of gap filler or interim technologies. It periodically comes up and people say, hey, this would be a great idea if we could do this, before getting overtaken by some other technology, and then people forget about it for a while and then it comes back again. And I think this is probably at least the third advent that I've seen of people saying, hey, why don't we have higher altitude platforms? And the reality is, you can do it better with LEO satellites. You don't need high altitude, low Earth orbiting platform fills a gap which LEO satellites have now filled. I don't really see the need for it. Again,
maybe it's technology that's missed the boat, which happens from time to time. Great. Sorry, Mark, I think I cut you off when we were talking about kind of ubiquitous mission critical communications in the context of looking at rival technologies to low Earth orbit. Were there any other points that you wanted to make on that strand?
Well, I think Jim probably actually made it, but I was just going to comment the fact that, LEO satellites go up with an average lifestyle of 10 to 15 years, 15 being, I think, more common. So once they're launched and in orbit, they will provide reliable, steady communication for that period of time. So, that gives people the surety that the network is there when they need it.
Sure. And that's what mission critical communications are all about. I think that's an excellent point to end today's podcast at. So thank you very much to Jim Morrish from Transforma Insights and Mark O'Collar from Globalstar for joining me today. I think it's been a very interesting discussion, and I hope that listeners have enjoyed it too. Obviously, we look forward to welcoming you back to another IoT Now podcast soon. Thanks for me.
Perfect.
Bye.
Thank you, George. Thank you, Jim.
Thanks, George. Be good to join you. Cheers.
Thank you.